Hi, I'm Mike Baker. Thanks for joining us today, Managing Director of TM Consultants, and we're going to be talking about the changes to the building code, specifically H1. I've got two helpers with me today, Jasmine, who's part of our modelling and sustainability team, and Laura, who runs our mechanical team in the South Island. So let's get into it, all exciting stuff.
So as Mike said before, today we're going to go through some of the building code updates. We're going to have a look at the overview of the current updates to the building code, the objectives of H1 specifically and the changes. And we're going to look at the new and updated climate zones, the performance criteria that's been updated, and some updated R values as well. So there's three codes that have been updated, H1, G7 and B1. So H1 has basically been split into three new codes that basically replace 4218 and 4243. G7 has also had some updates to its natural light code, and the same with B1 for structures, but I'll let you guys do that in your own time. So the objectives of the H1 changes are to lift the minimum levels of insulation to make warmer, drier homes for New Zealand, to introduce more climate zones to better represent the climate zones and the insulation levels that are within those climate zones, and also to make the documentation more simple and easy to use. So as I said before, they have updated the climate zones. We went from originally having 3 climate zones and now we've got 6. Like I said before, it just basically allows a more detailed or specific insulation level in those different areas. A more detailed table of these climate zones can also be found in Appendix C of H1 AS1, which is a little bit more specific than the map. And then the way that the code's now been split up is into AS1, VM1, AS2 and VM2. And the best way to understand this is AS1 and VM1 basically cover buildings that are less than 300 square metres, and AS2 and VM2 basically cover all the buildings that are larger than 300 metres squared. So you can kind of clarify this as residential for AS1 and VM1 and commercial for AS2 and VM2. Some other changes that have been made to AS1, which is replacing 4218, is that it no longer covers curtain walls. And when does this come into effect? Basically, they have come into effect on the 29th of November 2022. However, these you can still use the old H1 AS1 4th edition amendment to show compliance until the 2nd of November 2022, and it's still applicable for building applications submitted before the 3rd of November 2022, and H1 VM3, which we'll talk about later, also is come into effect now, so from the 29th of November. The H1 has still stayed the same in terms of the schedule method, calculation method and modelling method. However, there has been some minor changes. So for the schedule method, the window to wall ratio remains at 30%. So if your building is less than 30%, you can still use the schedule method. For calculation method, it has reduced down to 40%. So it used to be 50, but now it's 40%. So if your building has greater than 40% window to wall ratio, then you will require the modelling method. And and one of the major changes to the H1 code is the R values. So these R values here are for heated floors and heated walls and heated ceilings. So the top table represents the old R values and the bottom table represents the new R values. And as you can see, there has been a significant jump. For example, if we look at like the heated floor, for climate zone 1, 2 and 3 in the old code it was 1.9. However, if we look, for example, in Christchurch, which is climate zone 5, we can now see that heated floor has jumped up to 3, which is a significant increase in things like underfloor heating, and you're going to require a lot more insulation. So definitely something to be aware of. And the other thing that has also been updated is for rafters or trusses where the roof line is too thin and won't fit R6.6 or won't fit the insulation required, they have allowed for a 500mm out from the edge of the rafter to reduce it down to 3.3, so that you can sort of find that balance of still having R3.3 at the edge, but still meeting that 6.6 throughout the remaining structure of the roof. So there's a couple of little things like that are also important to be aware of. These ones here are for non-heated elements. So again, the top table represents the old R values, and the bottom table represents the new R values. Once again, you can see a significant increase, especially in places like the roof. So we've gone from R3.3 in climate zone 3 to R6.6 now, and the walls have stayed the same. This is because they still want to allow for that 90mm frame to be able to be used, which is quite good, but quite interesting. And then the same for all the other sort of elements. They have had quite a bit of increase, like for example, windows and glazing has increased, and now you're also required to have an R value for your doors. And again, with the skylights, they've also increased significantly. The previous R values I was speaking about were based on the residential code, which is less than 300 square metres. These ones here cover the commercial side, so buildings over 300 square metres. So again, this top table reflects the old R values for heated elements, and the bottom table reflects the new R values for heated elements. As you can see, there's a significant jump between the two. The old ceilings were required to have an R value of R3, whereas now across nearly all the board we're requiring at least R6.6, and in climate zone 6 we're needing R7, which is a significant jump from the previous R values. So these R values here cover the non-heated elements, and as you can see, the old R values for the roof is 1.9, for climate zones 1, 2 and 3. However, in the new R value requirements, we've got a significant jump ranging from R3.5 all the way up to R7 in climate zone 6, which is a significant increase in R values. Even the walls again have taken a massive jump. We've gone from 0.3 in climate zone 1 and 1.2 in climate zone 2 and 3, ranging from 2.2 all the way up to 3.2 in the walls, which is significant for commercial buildings. The floors had no requirement before, and now they've also had a significant increase in R value, and the same with the glazing, and the skylights now also are required to have a much higher R value than previously ever required for before. I'm now going to hand over to Laura, who's going to talk you through H1 VM3.
Cool, thanks for that, Jasmine. So now we're going to look at VM3. There has always been a clause in the building code that requires mechanical and HVAC systems to be energy efficient, but there was never any compliance pathway of how we actually demonstrate those systems were designed and installed as such. So now with the introduction of VM3, we have very specific requirements that we need to follow in both our designs and how these systems are built to make sure that they're compliant with the code. So some of the things that VM3 covers now includes the controls of the systems, how the systems are actually designed on plan, the kind of equipment we select, and then going forward through the life of the building, making sure that we're having maintenance access and energy monitoring, so we can make sure that we're tracking those energy efficient systems. There's quite a few requirements in this new code that we need to make sure we are complying with, so this can take a bit of time and require some input from us. So looking at some of those considerations, firstly, system controls. So some of the things that the code now talks about is zoning, so making sure that we have different thermostats in different rooms, for example. Making sure that equipment's turning off when they're not being used or only being run when the buildings are being occupied. Introducing things like economy cycles, VFDs, which are relatively common now anyway. Commissioning is an interesting one. We now have an upper limit on air conditioning systems, so just to ensure we're not oversupplying zones, and then also demand control ventilation. So just making sure we're ramping back the outside air when zones are have lower occupancy. In terms of system design, this is more about making sure that we're designing the ductwork layouts and things to have as low a pressure drop as possible. So things like making sure the ductwork is sized correctly to have a low pressure drop, minimising lengths of flexible ductwork, and then interestingly also things prescriptive as having straight lengths onto duct fittings and equipment to make sure that we're just really lowering the pressure drop as much as we can.
Can I jump in here, Laura, as well? So what impact is that going to have on sizing and spacing for ductwork around buildings, whereas traditionally the mechanical engineers were pressed and squished on some of the duct requirements because we didn't have the architecture large enough, and like the rest of the code that we've got for H1 compliance and making sure that we get, R6.6, how do we actually fit that into space? Now we've got a lot more ceiling space required. Is this going to mean that we need more ceiling space for ductwork because we no longer can squeeze things and just push more air through a smaller duct by a bigger fan?
Yeah, exactly. So previously, if we were constrained with space, we'd push our systems as hard as we could to make sure that we could work within the architectural constraints or within the structural requirements. But now we're actually going to have to think about this and comply with this and make sure we actually have those spaces that we need.
So for all the architects listening out there, might be getting a little bit of pushback now from some HVAC consultants saying, no, we actually need physically this amount of space for this. So it's a consideration. So if you go for resource consent, and you planned early on and you're wanting to plan out your rooms, your risers, how we get ventilation through the building, that's going to be a strong consideration now, because now we don't have a choice. We have to design for those minimum sizes of ducts to get the pressure losses right. So not really design and build contractor stuff anymore. This is quite specific design that's required. So, sorry, back over to you.
No, that was a very good point. The next one is equipment selection. So again, equipment selection is just about making sure we're picking the equipment that has the high energy efficiencies. There is quite a lot of added requirements on duct and pipework insulation now, where previously we'd usually spec, we didn't really have actually any specific requirement on the minimum R values on ductwork or pipework insulation. Now we actually have to meet those minimum R values, which means even more space required as well. And then interestingly, some of the ductwork components now have maximum pressure drop values that we need to comply with too. So things like fire dampers, you now only have 15 pascals to play with. So maybe in some locations we can't use those intumescent dampers anymore, and we have to go to a curtain style damper, which again takes up more space and needs to be considered from the outset. So yeah, a lot more stringent on those requirements. Next, there's maintenance access. So the VM3 is relatively vague on maintenance access, and the main guidance is just to refer to this Defence Works standard, but the requirement is just about making sure that sufficient access can be provided to all the services so that they can be maintained throughout the life of the building. Again, as what Mike was talking about earlier, this is something maybe usually we would compromise a little bit just to meet the other constraints of certain projects, but now we can't actually compromise that, and we need to demonstrate that we are complying with that. And then the final one is energy monitoring. So energy monitoring is split up into two requirements depending on how big your building is. The first one, for 500 to 2500 square metre buildings, it just says the energy meters are required for the HVAC systems. And then for buildings greater than 2500 square metres, you need separate energy meters for the heating plant, the cooling plant and the air handling plant. And all of that information for a minimum of 12 months needs to go back to some sort of central BMS or central logging, some central logging. Oh, crap.
Go.
So for buildings greater than 2500 square metres, you then need separate energy meters for heating plant, cooling plant or air handling plant. And this data needs to be collected and stored for a minimum of 12 months. This energy monitoring requirement is again just for the lifetime of the building to make sure we can design our systems at day one to be energy efficient, but we need to make sure that then through the life of the building they are maintaining that efficiency. So that's why this energy monitoring has been brought in. And that is it for VM3, and I'll hand back to Mike.
Thanks all for joining in and having a good listen. One of those things about energy metering and monitoring is that I guess neighbours compliant meters are a good way to do it. So if you're setting up a new building and you're having to monitor the system going forward, if we get neighbours compliant meters in there that can then record and store that data, that does tick one of those boxes. So in another session we'll be covering off the differences between the different tools Passive House, Homestar, Greenstar, Neighbours, and others, how they work, how much it costs, when do you get involved, who needs to do it, can you do it yourself, do you need to use consultants, just to really clear some of that air around the confusion that is energy metering things. So if you need any help, let us know. We're experts in this area, and hope you found it useful. A bit of a disclaimer, this is simply for educational purposes and to make sure that you know what's going on with the changes, but at the end of the day you have to comply with the code, not what we say, but we can help you get there. So thanks.